Welcome to Data and DataFrames for Finance 372. The first skill you need to acquire for data analysis is being able to load, view, and manipulate potentially large data sets. Many critical mistakes and wasted hours can be avoided by carefully viewing and examining your data before diving into your main analysis. What scale or units is each variable in? Are there observations that look weird or could be wrong? Does each column have the right data type? In Python, the standard way of loading and examining your data to answer these questions is using the Pandas and NumPy packages. So let's open up a new notebook and install those packages. As we covered in a previous video, the way you install packages is using pip install. So let's pip install Pandas and NumPy. I've already done that here, so I won't run them again. Next, we need to import these packages to use them in this notebook. So let's run this cell here. Our starting point is always going to be loading some data from an external source. One of the great things about this Pandas package is that we can load data from many different sources seamlessly. You can use an Excel file, a CSV file, HTML, Stata, SQL, many different sources, and it's always very simple. In our case, we have a file that's yieldcurve.csv, and the way we load these things is using the pd.read command. As you can see, when I type pd.read and then hit tab, the autocomplete shows me many different reading functions. So let's use the readCSV function, and then you just type in the name of the file. When Pandas reads a file, it creates what's called a data frame, and that's where it stores all of the data that it reads. Data frames you can think of to start like a table or an Excel spreadsheet. They have rows and columns, and we're going to get very familiar with them today. The convention is if you have only one data frame to just name it DF for short. If you have multiple data frames, then you want to name them each something underscore DF. So yields underscore DF or prices underscore DF. We're only going to have one in this notebook, so let's name ours DF. Now that we have it loaded, we might want to look at our data. There's lots of different ways in Python to look at your data. First, we can just type the name of our data frame and run this cell. By default, it shows us the first and last 5 rows of our data frame, and the names of the columns, and the index of each row. You can see this yield curve data frame has a maturity column, a date column, and a yield column, and 6,505 rows. We can also get some different information by typing df.info. Running that cell, you can see that this gives us a summary of the different column names, their types, and the number of observations in each column. We can also get the column names directly this way. All right, say if we want to see a few more rows than just those first 5 rows, we can use the command head and type in whatever number of rows we want to see. So head 12 will show us the first 12 rows of the data set. df.tail shows us the last 5 rows of a data set, or the last n rows of a data set. The default for head and tail is 5, so if we just say df.tail without a number, that will also print 5. The last thing we can do is view some summary statistics by using the describe function, so df.describe. And you can see it tells us the count, which is the number of observations in each column, the mean, standard deviation, min, and then some percentiles and the max. Okay, so this data, as you'd expect, contains yields ranging from negative to 15% and maturities ranging from 1 to 30 years. So now that we know how to look at our data, let's think about sorting our data. If we want to sort our data by one of our columns, we can use df.sortValues and then by equals the name of one of our columns. So this will sort our data by the maturity column. Now, if you enter this command, it will do that sort, but it won't store the result unless you do this, df equals df.sortValues. So we do the sort, and then we store the result back into the name df. So going forward, df will be sorted by maturity. So if we do another line here with just df on it, that will display the resulting data frame. So if you run this cell, you can see that the data frame now is sorted by maturity, with all of them in maturity 1s first, all the maturity 30s at the end. Okay, but you can see within maturity, these are in sort of random order. They're not ordered by date, they're not ordered by yields. Okay, we can do a sequential sort where we sort first by maturity, and then within maturity by yield, using a similar command. So instead of writing by equals maturity, we can do by equals maturity, comma, yield. And this will sort by maturity, and then within maturity by yield. So let's display that again. And you can see here, this is working correctly. So by default, sorts are ascending, so it puts the smallest values first. We can make them descending instead by using df.sort values by equals maturity, ascending equals false. By default, the ascending parameter is true, so you don't have to type ascending equals true. If you want to override that default, you do need to type ascending equals false. This will, of course, make it descending. So now you can see that our highest yield observations are first. So instead of sorting a table by rows, we can also sort a table by columns using the sort index command. So df equals df.sort index, and then we have to tell it that our axis equals 1. Axis equals 1 is sorting by columns. So this is going to sort the columns alphabetically by name. As you can see now, the columns are date, maturity, yield, whereas before they were maturity, date, yield. Okay, now we can go back to our original sorting by doing another sort by index, but this time by the row index. So df equals df.sort index. By default, we're going to use the axis equal to the row index. What we get back is our original sorting we had when we first loaded the file. Okay, next up is selecting a subset of the data so we can start thinking about manipulating it. All right, there's a lot of different equivalent ways of doing this using Pandas and Python. I'm going to show you a few different ones and I'll tell you which one we prefer. Okay, so let's say I want to select the maturity column. I just want to manipulate something that's happening in the maturity column. I can do that using df open bracket maturity in letters or df.maturity. But the preferred way to do this is using a command called loc for location. Loc takes two different parameters in square brackets. The first is something that tells you which rows to look at, and the second tells you which columns to look at. So for this, in this case, if we want to just get the maturity column, we want to look at all the rows. So this colon indicates that I want to look at all of the rows. I don't want to look at all of the columns. If I did this, this would be all the rows and all the columns, but we don't want all the columns. We just want the maturity column. So I can do that here. So if I run this cell here, you can see that if I just look at what maturity C is, what I've got now is just a column. It's not a table anymore. It's just a column with the different maturities in it. You get the same thing for either one of these commands, but this is our preferred way of doing it. You'll see why as we go. Okay, next, instead of selecting columns, let's select specific rows. Maybe you only want to look at, for example, the first 8 rows of your table. Okay, we already talked about one way of doing that, which is the df.head command. You can also use df square brackets 0 through 8. This 0 through 8 is a little bit confusing at first, but the reason for this is that Python uses what's called zero indexing. So the first row has an index of 0, not 1. So we start counting at 0 instead of 1. You can see that right here. And up here, the first index is always 0. Okay, so what this command says is I want to take out of my data frame, I want to start with the 0th row, and then I want to grab 8 rows. I'm going to go up through the 8th row, which of course has an index of 7. So this is actually indices 0, 1, 2, 3, 4, 5, 6, 7. All right, and if you're starting from the beginning like this, you can omit the 0 and just say :8, which means to give me everything up to the 8th one. Another way we can do this is with the iloc command, which uses integer location. So now we're looking at locations like we did before, but instead of writing them out with letters, maturity, we're going to just write them out with numbers, so we just want to go up through the 8th one. All right, but that's still not quite the preferred way of doing it. The preferred way of doing it is this, df.iloc. So again, we're using integer locations. We want to go to the 8th one, but we want to specify that we want all of the columns. Okay, so you can start to see one reason why I prefer to use loc and iloc in my code is because I'm consistently making myself write both which columns do I want and which rows do I want. So this makes sure I'm not mixing up rows versus columns and making myself think, okay, do I want all the rows and do I want all the columns, and putting that in here. Okay, if instead we wanted to select the last 6 rows, one sort of crude way of doing that would be to say, okay, well, we have 6,505 rows. So I want to start at 6549 index and go to 6505. I want to go up to, but not including the 6505 index. And that would work, but then you have to look up every time exactly how many rows are in this thing, so it's a little annoying. All right, now a trick that they built into Python for us is if we want to just get the 6th last rows, we can actually do -6 colon. So -6 says start at the beginning and then loop around 6 towards the end. And we also have tail 6. We've talked about that already. And now for iloc, you can use this negative location. And again, the preferred thing I would use is this, because I'm going to specify both the row and the column. So rows, I want the 6 last rows, and then I'll take all the columns. Okay, so I can run this code, and then now let's look and see what we got out of this. The first 8 look like this, and the last 6 look like this. All right, now let's try to select some rows somewhere random in the middle. The way we recommend you do this is using, again, the iloc command, iloc, and then now let's just choose some random numbers, so 2505. So this will take indices 2500, 2501, 2, 3, 4, and that'll be 5 total. And we want all of the columns. Okay, so we run that this way, and you see what we get is 5 rows selected from the middle of this data frame. Now instead of selecting all the columns for these 5 rows, let's just get the second and third columns. So that would be maturity and yield. So let's say we only want to look at the maturity and yield for these columns. Okay, there's a few different ways for doing this. We can use our df.iloc command, and iloc requires you use integer column and row indicators. So we want to get the second and third rows. That's 1. Remember, the second row has an index of 1. And then we want to go up to, but not including the third, an index of 3. So this is again our notation for the second and third columns. You can see now we got maturity and yield for only from these 2 columns. This is a little bit confusing and ugly to do, like 1 to 3, what does that mean? Maybe I want to instead say, specifically, I want the yield and maturity columns. I want to use the names instead of the integers. All right, so the way to do that is you can combine an iloc and a loc command, but you have to do it in 2 steps. So again, let's do middle. Let's get all of the columns in the middle. And to use that, we use the iloc command. All right, and then we can grab just the columns we want by using the loc command, which uses letters instead of numbers. So once we have the complete rows in the middle that we want, we can use the loc command to grab just the columns that we want. So what we want is just middle sum columns, and we take the middle all data frame that we just created, and let's grab all the rows in this little data frame, but just the columns maturity and yield. All right, and let's look at that. All right, there we go. So we get the same thing this way as this way. The advantage of this second way is just that you instead of typing 1:3, you're doing maturity and yield, which is easier to understand and read. A much more common situation in practice than wanting to select rows by just their numbers is to select rows by a Boolean condition. So we want to say, let's grab all the rows that meet a certain condition. All right, so let's say we want to look at this big data set of yields and only look at the 30-year yields. So the way to do that is very similar. Again, we're going to use the loc command. So we're going to df.loc, and then we're going to grab now a Boolean condition. So we put in here which rows do we want. We want the rows where df.loc, where our maturity is equal to 30. Okay, so this is like the previous Boolean commands we've done where you use the double equal sign to say, I want this to equal that. Okay, now what I'm doing is I'm saying, grab me the maturity data I have and compare that to 30. When that's true, we want to grab that row. Otherwise, we don't want that row. All right, and then we're gonna grab all of the columns. Okay, so this first condition here before the column tells Python, okay, look at these rows, the ones that meet this condition, and then give me all of the columns. All right, you get a new data frame that has only 926 observations, and those observations are all of the ones with maturity equal to 30. All right, just to practice here, let's do the same thing again, but now let's only grab the date and yield columns because those are the ones that are going to be the most useful here. We know the maturity is 30, so we maybe don't need to keep that column. So to do this, let's grab this and copy and paste it down here. And then let's just change this here to say we don't want all of the columns, we only want date and yield. Run this again, and now you see we get the same thing, but only with 2 of the columns. All right, so an important note here is unlike when we were doing the if statements before, where you could type the word and, A-N-D, and or, O-R, here we need to use these symbols instead. A single and symbol, which is, or ampersand, or a single or symbol, which is this vertical line here. All right, so to show how this works, let's say we want to select all of the rows that are between 2% and 3% yield. All right, to do this, we need to combine 2 different Boolean comparisons. We need to check whether the yield is above 2 and check whether it's below 3. And we need both those to be true. Okay, so there's going to be 2 important things to keep in mind when you're doing multiple Boolean comparisons when filtering your data. The first is that you want to put the 2 different conditions in parentheses here. So I'm just going to write this out like this to remind us of how the big structure works here. Okay, so we need to have this condition true and this condition true, and then we're going to grab all of the columns. All right, so what are the two conditions? Well, the first condition is that our yield, so we want to grab all the different yields and compare them to 2. So we need to be, let's say, greater than or equal to 2. All right, and then we also need, we can put a space here, the yields to be less than 3. Okay, so now if we do it this way, we get this. Our resulting data frame has 1,000 observations or so, all of them with their yields between 2% and 3%. All right, so if we want to verify that, we can do 2perkyields.describe and see that the minimum is 2.0002 and the max is 2.9997. So lots of times in finance, we'll get data sets that have a column or two that indicate dates. We have a column in this data set that is a date. Often what happens when Pandas loads data sets that have date columns is it doesn't quite recognize them right away as being date columns. So if we go back to this df.info, we can see that right now our date column has a D type of object. So object is sort of the generic type that Pandas assigns when it just isn't really sure what that object is. If we want to start sorting these dates correctly or start adding different years or dates to them, we need to correct this mistake and have this column have a type of date times 64. Fortunately, the way to do this is pretty simple. We can use the pd.toDateTime command. So this is from the Pandas library, and we can use the toDateTime command, and then we could put any column we want in here and we'll convert it to a date time column. So let's take the date column out of our data frame, convert it to a date time type, and then let's assign that back to the same column. So we want to create the new date time column and then assign it back to the original object column, which replaces it with what we want. So now if we do it this way, we do this replacement and run the df.info again, we get now that this type is what we want, date time 64. Okay, with that, we can do cool stuff like, for example, select only the data from the 1990s using, again, a combination of two different if statements. So in this case, we have an if statement making sure that our date is greater than the first day of 1990 and less than or equal to the last day of 1999. Actually, let's make it greater than or equal to here as well. All right, and then we can see how this works is we get a new data set with 840 rows only in the 1990s. Now, if we want to add a time interval to a given observation, we have to use something called a time delta. All right, so in this case, a natural application of this would be to take our observed date and maturity and compute a maturity date. All right, so the formula for this we're going to use is that the maturity date is equal to the current date plus the number of maturity years times 365 days. Okay, this time delta command, what it does is it takes a timestamp and moves it up or back in time by a certain amount of hours, minutes, or days. You cannot put directly in there years or months because months could be a different number of days depending on which month you're talking about, and years could mean 365 days or it could mean 365.25 days or it could mean thinking about leap years, so it's sort of ambiguous. To correct that, they make you just use days and then tell it, okay, do you want 365 days? Because I can do that. So we're going to use 365 days for our year. So we can compute our maturity dates by taking our initial date and adding a time delta. The way you get your time deltas is using the Pandas library, pd.toTimeDelta. This command takes two parameters. We have to tell it what is our quantity. So 65 is a quantity. In this case, we're going to have the quantity be the number of maturity years. So our quantity could be 1, 10, 30. And then we're going to multiply that by 365 to get a quantity of days. So this is the number of days we want to move forward. So the number of days we want to move forward is the maturity times 365. Okay, and then we need to tell Pandas that these are days. And the way you do that is using the second parameter, which is a D in this case. Could also be a H for hours or M for minutes, but we're using days, so D. Okay, so this maturity date now will reflect these different times to maturity and trading dates. And so you can see here we have maturities going all the way out to 2048 for the 2018 observation of a 30-year bond. I know a lot of the stuff I've showed you so far you can chain together. So you can do one thing that sorts it and then another thing that describes it all in the same command. So as an example of this, let's describe the 10-year yields in the 1990s. All right, so to do this, let's go back to a command we had before where we got everything from the 1990s. And let's copy that. Second, we want to describe this data. So now we take advantage of the fact that this command I have written here produces a data frame. And once it's a data frame, we can then run commands on that data frame. So we can describe the data frame. Okay, if we run this, we can see we get this description here of what were yields like in the 1990s. All right, in addition to viewing and sorting and querying data, we're also going to want to change our data sometimes. Before we start changing our data, we want to save a copy of our original data. All right, so we're going to try to create a df2, which is this second data frame that it's going to be the one we're going to play around with and change the values of. Now, you might think an easy way to do that is just saying df2 is equal to df. And that does work in the sense that you do get something called df2 and you can change it. But when you do that, you also change df1, the original df. Okay, because this df2 equals df, the way this works in Python is it does not create a copy. It makes a new reference to that same data frame instead. So if you modify df2, it also modifies df1. If you want a true independent copy, you have to use the copy command. So df2 has to be equal to df1.copy. Now we have df2 as completely separate from df1. We can modify it however we want, and then we don't lose our original data frame df. All right, so this is in general a good practice when you're modifying something, is you don't want to discard what you had before in case you ever want to go back to it. All right, so now let's do some modifications. Once we know how to query our data, it's fairly easy to modify it. So let's go back to that query we had before and set all the 10-year yields in the 1990s to have a 5% yield. So let's paste that same query that gets us all the data in the 1990s, but now we want to do it for df2, our free to modify data set. Okay, now we want to set the yield though to 5%. Okay, so instead of just viewing this data, we actually want to set the data to something else. All right, and then just to see what we've done, let's do a view here where we, instead of setting that to anything, let's just look at the entire set of columns for this query. So you can see here that this df2 now has all of the 1990s 10-year bonds with a yield of 5. Okay, so we've overwritten all of the original data. Okay, so instead of changing just a subset, we can also change an entire column all at once. Something we might want to do in this data frame is divide that yield by 100. So instead of a percent, it's a number more like 0.05. This is going to be better for doing some math in a minute. Okay, so let's do df2, and we're going to change the yield column to equal the original yield column divided by 100. All right, and then let's have a look at what that makes it look like. Okay, so now our yields are 0.025 instead of 2.5. With that in hand, we can now go back to our lessons from 367 and compute the price of these zero coupon bonds based on the yields to maturity, and let's assume a face value of 1,000. Okay, so the way we're going to do that is we're going to create a new column in the data frame. We can again use the loc command to say I want to create a new column. This is going to be price, and this is going to be based on $1,000 divided by, and then we're going to let me just write out the formula first. It's 1 plus y to the n, where y is the yield to maturity and n is the years to maturity. Okay, so in this case we have y. We can get the yield to maturity by using df2.loc yield, and then to use to nth power, remember we have to use 2 multiplication signs or 2 asterisks to do a to the power of b. So in this case we want to have our maturity, which is again from df2.loc. Okay, and then we need to add some parentheses to make sure that we're dividing 1,000 by all of this. Now let's see if that worked. Okay, you can see in here our prices have an average of 674, a high of a little bit above 1,000, and a low all the way down to $15. Okay, the median looks reasonable, right? These are supposed to be zero coupon bonds with a face value of 1,000. But that minimum looks really low, $15. Could a zero coupon bond with a face value of 1,000 really have only traded for $15? All right, so let's do a quick check here. So first, let's look at the part of the data frame that has these really low prices. So let's use low prices. Let's set that equal to df2. Let's sort by price, and that's going to sort ascending, so we're going to get the lowest one first. And let's grab the lowest 10 by price. That'll be low prices, and let's see what low prices look like. Okay, so we have these observations that have prices of $15. You can see they all have really high yields to maturity. So let's just do a quick back of the envelope calculation and say if we have $15 as our present value times 1 plus 0.15, that's 15%, to the 30th power Okay, that gets us back to 1,000. This is reasonable. All right, the last thing I want to talk about today is what happens if you have missing values in your data. Very common in practice where you load up historical data and certain companies just have data missing at certain times. All right, so let's just, as an example here, this particular data set didn't have any missing data as loaded, but actually maybe we want to make some of it missing. So maybe let's say that we have this yield to maturity in here that is negative and we don't trust it. All right, so let's go back to our original data frame and let's sort it by yields. And you can see that we have this one observation with a yield that's negative 2% and nothing even close to it. So that makes me wonder if something's a little bit funky with the data. Maybe that observation is misrecorded. At the very least, I want to make sure whatever I'm doing is robust to ignoring that observation. So how do we ignore that observation? Well, what we're going to do is we're going to use this something called an NaN, or not a number indicator, and that's going to be in the place of any data that we think is missing. So to replace that negative yield observation with NaN, or not a number, we use our lookup here where we say let's locate the, we want to locate rows where the yield is negative. We want to look at that yield and set it to NaN. The way you get NaN is using NumPy np.nan. All right, so let's see what happens to our DF when we do that. You can see now that this one observation now has an NaN in there. Okay, and this is going to be our general indicator for some data is missing. The good news is once you have the correct observations coded as missing, you don't need to worry too much how to handle that because most operations in Pandas will just ignore missing data. So for example, if I do df.describe here, it's still going to calculate my means and standard deviations for these yields, even though one of them is an NA missing. All right, and the only thing you notice here is that now the count, which is the number of available, not missing data, is now a little bit smaller for yield because we have one missing observation. All right, so this shows you the kind of viewing and experimentation you can do with a data set, and then how you can manipulate it by setting different parts to different values, combining different columns into new columns, and sorting the results in different ways. It's very important when you start a new project and you load some data, not to just blindly trust what you get out of it. I hope this is a process you use every time you open a new data set to really understand what's in there and if there could be anything wrong with what you're looking at.